All right, hey Megan. 3-5, we're starting notes today. This is the homework assignment for that, so if you need to pause, there it is. And here we go. One thing that is different from the last couple sections is that we are doing equations now. So we have exponential and log equations, which involves an equal sign. So we're going to actually be solving for some things, right? Okay, rather than just simplifying, like logs, putting things together, whatever, right? Okay, here's the deal. When we start to solve exponential and log equations, if you get stuck in one land, right? If we're in exponential land and you get stuck, switch it to log land. If you are in log land and you get stuck, you switch it to exponential land, okay? You go back and forth between the two, and somehow, some way, you will end up solving it. All right, here we go. I'm going to skip this, and I'm going to show you what this illustrates down here with example 1. So here we go. This is a log or an exponential. Which one? This is an exponential. So we are in exponential land. All right. And we're trying to solve this thing. Okay, we have an equal sign right here. And I have 3 and I have 81. And those are like both bases, basically. This is like 81 to the first power. Okay, don't put that down. But I have 3 and I have 81. Now, this is really nice because I can write 81 as a base of 3. So I can write 81 as 3 to some power. Do you know what that power is?
9.
No. What?
Wait, 3.
3 to what power gives you 81? How many times should you take 3 times itself to get 81?
16.
4. 4, right? If I have 4 threes, 3, 3, 3, 3. This 3 and 3 makes 9. This 3 and 3 makes 9, and this 9 and 9 makes 81, right?
So
it is 3 to the 4th power. Yeah. Yeah.
Pardon?
Look at you go. Pardon? Yeah, we were all sleeping. Here we go. So now I have this going on, right? And now my bases are the same. I have 3 to that junk power equals 3 to the 4th power. And then what happens? This cancels because they're the same now. And we have 2x minus 6 equals 4. And then I do the math, right? Which Delaney just did perfectly in her head. She added the 6. So 2x equals 10. And then if you divide by 2, x is 5. Look at her go. Too smart. Beautiful. Okay, good. Beautiful. Okay, B. There may come a time when you have to change the base of both sides. Okay? So I look at 25 and I'm like instantly thinking of like an easier number. 25 is 5 to the 2nd power. Yeah? Right? I can change 25 and make him 5 to the 2nd power. But there's already a 4 minus t there. We're going to deal with that here in a second. How can I change 1/5 to be a base of 5? 1/5 is 5 to the what power? -1, right? Okay? If you're going from a whole number to a fraction, 5 to the -1 power makes them 1/5. Yeah? But I still have this 3t plus 1. Right? Okay, we're going to deal with him in a second. So, I have changed the base on both sides. I've made them both 5. Okay? All right, now, before we cancel the 5s, or I guess you could do these at the same time if you get used to this and want to, like, do multiple steps at once. Before we cancel the 5s, I take this 2 right here, and what do you do with him? Yeah, I distribute him through. It's like multiplication. I take this -1 and I distribute him through. So this is now 5 to the 8 minus 2t power equals 5 to the -3t minus 1. Did I do that right? I have changed the base on both sides to be 5. And now, since it's 5, I can cancel both of those. Now, you could have done that all in the same, at like one step, which is fine. So now I solve 8 minus 2t equals -3t minus 1.
7 minus 2t. Or what? No.
You're close.
7 minus,
I'm going to add the 3t over to make it positive t. So if I add 3t here and I add 3t here, -2t plus 3t is 1t. And if I do that, I'm going to bump the 8 to the other side. So t equals -9.
Close enough.
Yep, you were close. You said 7, which is like,
2 off. 2 off.
yeah. Actually, it's 16 off, but
Oh, yes.
if it was positive.
-7.
Oh, okay,
I said
-7. All right, now you're only 2 off again. Okay, but you see how that works? If we're in exponential land, my very, very first thought is to change the bases to be the same number, because then I can just cancel and do all the math, all the algebra. That's exciting to me. All right, now we get to something like this, and this is a little bit more complicated, and here's what this looks like, okay? Example 2 says 7 to the x power equals 60. We are still in exponential land, true? Like, we're still dealing with exponents, but can you write 60 as like 7 to the third power, or 7 to the fourth power, or 7 to the fifth? Like, will I make 60 out of 7s? 7 squared is 49. 7 to the third power is like really huge. I don't think I can make 60 out of that. So, we're stuck. My whole like strategy of trying to make them the same bases fails. So, I just said to you up above, if I'm in exponential land and I am stuck, I am going to switch it to log land. Okay, now we have a couple options. Okay, don't write this down. You decide which option you want first. Okay, here's what I can do. If I have 7 to the x power equals 60, what I can do in order for this to be legal is I can add a log in front of both sides, right? I can add a log. What's the base of that log? 10. Okay, I can do that, all right? And by adding a log in front, I can now do something with this x. What?
Bring it out in front.
Bring it out in front. I'm going to pull the x down in front. So now I have x times log 7 equals log 60, right? Okay, and now what if I want to solve for x? Yeah, I'm going to divide by log 7. So I just have log 60 divided by log 7. And that's what x is, whatever that decimal number is. So make sure that if you're going to type this in, you close off your parentheses after 60, whatever.
Everyone's good job.
Oh, before you give me the answer, don't give me the answer yet. Okay? About what will the answer for x be? 7 to some power gives me 60.
Probably like
Between 2 and
7 to the second power is 49, right? 7 to the third power is a really huge number.
2.2.
So it's going to be probably like between 2 and 3, right? Okay? And it is what? Give me 4 decimal places.
2.1041.
1041. There you go. There he is. Okay? Now, you have options. Okay? So I could do this another way, but it's basically the same procedure. If I have 7 to the x power equals 60, I don't have to use log, right? I don't have to use the log button. I could use the ln button if I want to, right? It's less writing because, I mean, you have like one less letter. But if that's the case, I can still move my x down in front. So x times ln of 7 equals ln of 60, right? And then if I divide by ln 7, I have basically kind of the same thing. Before we had log 60 divided by log 7. Here we have ln 60 divided by ln 7. It's going to give me the same answer. So I don't care if you use log or you use ln. It doesn't matter. Okay? And you put that in front of both sides. So when do you do that process? When do you do that process? When do I log both sides?
When you don't know the
When you can't get these two numbers to be the same base. Like up here, I could change the 3 and the 81 to be both sides of 3, right? Here, I could change them both to be 5s, right? I cannot change both sides to be 7s or whatever, right? So when they won't change bases to be the same number, that's when you have to log both sides or ln both sides. And then your exponent comes down and all the things, right? Okay, all right, here we go. So we have this guy. Okay. Procedure. What shall we do?
minus 820.
Let's minus 820. Let's do all the algebra first. Minus 820. Okay, he's gone. Now I have 10 to the 5 plus 2x power equals 48,780. Okay, now I have an exponential function, right? And I have a base over here that is 10, and I have a base over here that is that big number. Can you write this number as 10 to the third power, or 10 to the fourth power, or 10 to the fifth power? No, that's not going to work. So what do we do instead? We do log or ln, right? In this case, log would be easier, okay? In this case, log would be easier. Wow. How come? This is where, like, Avalee comes into play, because she says, look what happens.
Cancel.
This is log base 10, right? And log base 10 and 10 cancel. Hey, that's nice. So now one of my logs is gone. 5 plus 2x is the only thing I have over here, and this is log of, you don't need the parentheses, but I'm going to put them in there anyway. Log of that thing, right? Okay? Now what? I'm solving for x. Now what?
Just find
Solve for x. What are you going to do first?
5
40,
question?
70.
So subtract the 5. Okay, now you've got to close your parentheses before you subtract the 5, right? And then what would you do after you subtract the 5
Move it.
to solve for x?
Divide.
Divide by 2. So I'm going to take that whole thing and I'm going to divide by 2. If you want to type it in all at one shot, you sure can. But log that huge number, minus 5, divided by 2.
0.1559.
There you go.
Oh, negative 0.
Negative 0.1559. Okay, we'll take it. Okay? You see how that works? You do all your algebra stuff first. Then you insert your logs when you're absolutely out of anything. All right, now what?
Be done.
Nope.
We have do you know that this
We're solving for
has
T.
12 examples?
What?
This lesson?
Muh.
12.
Yeah, but they're short though. Like these are all algebra problems.
Yeah.
Okay, we'll get done with part of it today. All right, well, we're solving for t, right? T's up here. Okay. All right, what are you gonna do first?
ln.
Okay. Do you wanna step-by-step list? Steps. Number 1, do any algebra first. Do any algebra first. So, in this problem, part B, can I do any algebra? No. I'm trying to solve for t. I'm trying to get it away from that. Right? So I'm going to divide by 18,000. Right? So get them to the other side. Okay. T is over here. I'm going to go away, right? So those are going to cancel off, right? 2 over 18 is 1/9. All right? Which is 0.1 repeating. I'm going to leave it as 1/9. And that's e to the negative 0.4t. Okay. All right. That was step number 1. Do any algebra first. Can I do any more algebra? I don't think so. Step number 2. Try to make same bases. Okay. Try to make same bases. So what's my base number on the left side?
9.
1/9. What's my base number on the right side? E. Can you make those two numbers be the same? I don't think that's going to work.
No.
Okay, so number 3. What do we do if we can't make them the same basis?
Log.
ln or log both sides. Okay, if that's the case, you're ln or you're log in both sides. If that's the case, do you want to use ln or log in this case? Why ln? Because the ln and e are going to cancel. Whoop. So I have ln of 1/9 equals negative 0.4 t. If I'm solving for t, divide by negative 0.4. So I'm going to take ln of 1/9, whatever that number is, and divide by negative 0.4. Make sure that if you're typing this in and you're using parentheses and you're doing it all at one shot, you close your parentheses. If it were me, I would do ln of 1/9, enter, divided by negative 0.4, enter, right? T equals
5.493.
5.4931. Yeah? Okay. All right, those are your steps. Do algebra first. Try to make them the same basis. If it doesn't work, ln or log both sides. All right.
All right, now we're done.
Example 4. We gotta do all of the. We're gonna skip example 5 because I don't want to do that one. But we're gonna do example 4, and then maybe we'll stop. We'll do example 4 because that'll be a nice cutoff right there. Okay. All right. Example 4. Step number 1 says do what?
Algebra.
Do algebra first. Can you do any algebra?
No.
No, because like the x's are trapped up there, right? Okay, so we can't do anything. So step number 1 fails. Step number 2, can I make, what are my bases? What are my base numbers? 4 and 5. Can I get those to be the same number? Like 4 I can write as 2 to the 2nd power, right? Can I write 5 as something?
No.
No. Can I write them as the same base? Now, so I either have to ln both sides or log both sides. Which one would you prefer? They're both going to be disgusting at this point, right? Okay, so let's log, Remington says. Okay, this is going to be a disgusting problem. Okay, this is going to be a really disgusting problem. Blech. All right. Okay, and the algebra is going to be gross. Okay, by logging both sides, now what can I do?
Find the base.
No.
No, we can't cancel anything. Not in this case because it's 4 and 5. What do we do after I log both sides?
Oh, bring the thing out in front.
Bring the exponents down in front. Okay, let's bring them exponents down in front. And because they're like binomials, they're like two pieces, I'm going to do parentheses. So 2x minus 7 comes down in front times log 4. Okay? Equals, parentheses, 3x plus 1 times log 5. Okay, now what shall we do? Now it's all on like one playing field right here. And it's going to be kind of gross. Now what?
Simplify logs.
Simplify the logs. Okay, you want to type these in? Log 4, what is log 4? 4 decimal places.
0.6021.
0.6021. Okay, what's log 5?
0.6990.
0.6990. Okay, all right, here's where my options come into play. Are you ready for your options? Here's my options, okay? I can distribute this through, and I can distribute this through, in which case I will have 4 pieces total, and they all will be decimals. Hold on. Just wait. Do you see what I just said there? So we simplified this log, we simplified this log. If we distribute there and we distribute there, we'll end up with 2 pieces there, 2 pieces there, and they all will have decimals. Or,
Leave them as logs.
no,
We leave them as
or I can divide by 0.6021 and divide by 0.6021, get that decimal number and distribute that through, and I will only have decimals on the right side. Does that make sense? Would you rather do that? Yes? Now, it doesn't matter which side you divide the log. I could divide the left one over to the right one. It doesn't matter. Which way would you rather divide? How I have it? Okay, so we're going to divide by 6021. So that means he's gone over here. So 2x minus 7 is just chilling. Equals. I've got 3x plus 1. He's just chilling for a second. And if I do those divided by each other, can you, Rem,
Wait, what?
if I divide those two logs, right? So it's like log 5 divided by log 4.
It's 1.1609.
1.1609. Did you use the full decimals? Did you retype it? Yeah, let's use the full decimals. 5. 5 divided by 4. All right, he's going back and using log 5 divided by log 4 instead of the decimal.
1.1610.
10. Okay, so it's slightly changed. Whatever. Okay, so now he's on the right side. Now what?
I had to press them.
Now what?
Times that.
What?
3 times 1.
We're going to take this guy and we're going to distribute him through. So 2x minus 7 equals 1.1610 times 3. 4.83x plus, what's this guy times 1 if I distribute it through? The same thing. Okay, now, do you see where we're at right here? We have how many pieces? 4. 1, 2, 3, 4. Here's my equal sign. We got to get the x's together.
Subtract 2x.
You want to subtract the 2x? Okay, let's minus the 2x. You can do that in your head. I'm going to go down here. Blah, 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 blah. So 2x goes away. What's 3.483x minus 2x?
1.483.
1.483x. And then what?
Plus.
Bring over the, no, subtract.
I'm going to subtract the 1.1610 minus 1 point. You can do that in your head too. Negative 7 minus 1.16.
8.1610.
Yeah.
Why do we need the 0 at the end?
You don't. And then we are going to last divide by 1.483. Divide by 1.483. X equals Negative?
5.5, no, 5.5030, negative 5.5.
Yep, negative 5.5030, or you could just say 503. Okay? So, it's just one big fat, like, algebra problem. Okay? Good. You can go up to solve log equations, because we haven't done any of those. We've only solved exponential, which is a good place to stop. But I need to know where we're at here.
Get through 28.
Solve.
Oh, no.
No,
28,
That's 3 for
which is 34. But
3, 5, 3, 5,
Where are we at?
3, 5.
11:30.
Solve exponential equations. Solve log equations. We can get through 34. So 28. There you go. That's about half, right? That's slightly over half. You can do 7 of the 13. Ooh. Okay? Good? Happy with that? All right. Bye, Megan.